Hello students, this video is to help studying for the polynomial operations quiz. I'm going to go over some of the problems from the lesson 3 practice and hopefully try to dispel some of the questions that you might have. Now I've already given you the full answer list and I'll also show that at the end of this video. But first let's take a look at the first one. I know that we're looking at 7j to the third minus 2 plus 5j to the third minus j minus 3. And we should try to remember that I gave you a couple of rules in class. Let's review those rules. If you're adding two polynomials together, you should remember that adding polynomials, you must remove the parentheses. So anytime you're adding two polynomials together, you don't need to do any distribution, you just remove the parentheses. So I have 7j to the third minus 2 plus 5j to the third minus j minus 3. I'm just going to remove the parentheses and then I'll take it from there. So you can see that I removed the parentheses and I've set it up so that it's all in one row. Now what I'm going to do is identify the like terms. I know that I have a j to the third here and I have a positive j to the third here. It looks like the j is all by itself, that's a single variable term, and then we have a negative 2 which is a constant term, and a negative 3 which is a constant term. Now what I'm going to do is combine these as like terms. So you can see I combined them to 12j to the third minus j minus 5. Let's take a look at another addition problem to make sure you get it right. Let's take a look at number 6. You can see in number 6 they're not in standard form already. Looks like the 4x to the third should be in the front. This 3x should be here. But we can do the same exact procedure. We're adding polynomials. So all we need to do is remove the parentheses and then combine like terms. And you can see we've written the two polynomials out. We've removed the parentheses. So now we will identify like terms and combine them. I have a negative 4x. That combines with a negative 3x. I have a positive 4x to the third, which is going to combine with positive 3x to the third. And I have two constant terms that I'm going to underline 3 times. And those are going to get combined as well at the end. So you can see that this is the simplified version. It's got negative 7x, which is negative 4x plus negative 3x. It's got positive 7x to the third, positive 4, positive 3. And keep in mind, we're combining like terms. When you combine like terms, the variables and the exponents stay the same. For example, negative 4x and negative 3x combined to negative 7x, the x stayed the same. But keep in mind we must write these in standard form, which means the largest exponent comes first. So standard form would look something like this, having the 7x to the third first, and then the negative 7x, and then the negative 2. As a reminder, this term has a degree of 3, degree of 1, degree of 0. Let's take a look at a subtraction problem. And the subtraction problem that I want to look at is problem number 11. Now keep in mind with subtraction problems like the one I have here, that the rule is a little different. I can't just remove the parentheses. I have this negative sign here in between the two polynomials, and in order to get rid of that negative sign, I must distribute. So this is the negative sign I'm talking about. And what I need to do with this negative sign is distribute it to the second polynomial. So I'll distribute it to the 7x, I'll distribute it to the negative 3, and I will distribute it also to the negative 7x to the third. It should look like this. So that distribution made all of the terms the opposite signs. This positive 7x became negative 7x, the negative 3 became positive 3, and the negative 7x to the third became positive 7x to the third. Looks like I left a parentheses in there. Now I need to combine like terms. I'll identify them first and then combine them. So you can see I have a negative 2x to the third and a positive 7x to the third, x and negative 7x, and also 3 as my constant term. Now combine like terms. So that should give us 5x to the third minus 6x, and that's 7, or that's a negative 7 and a positive 1 that I combined to get negative 6, plus 3. So that was number 11. Let's do one more subtraction problem to make sure you get it right. Let's take a look at number 14. And as you can see, number 14 is a fairly long problem. We have a trinomial, and then minus a polynomial with 4 terms. And all we need to do here, the same thing, is distribute that negative sign. So the first step I'll take is take this out of the parentheses and make every one of these terms its opposite sign. Now I didn't draw the arrows here, but you can see that the positive 7x to the third became negative 7x to the third, negative to positive, positive to negative, negative to positive. Now I'm going to combine like terms. And you can see the procedure that I used here. If you need to, pause the video and take a look at the exact terms that I've underlined and just make sure that we've combined these terms correctly. I promise you, I have. Now we've done addition and subtraction, let's take a look at some of the multiplication problems. Let's start with one of the single distribution problems, like number 20. Number 20 has one variable term outside and 2 variable terms on the inside of the parentheses. We'll distribute, which means multiply. So if you recall, when we multiply 2 different terms together, we're going to multiply the coefficient times the coefficient, and then the variable times the variable. So let's do the first one. In the first one, we have 2 coefficients. We have 5 and 2. When we multiply them together, we should get 10. And then for the second part, we have x to the third and x. When we multiply them together, we should get x to the fourth. Remember, multiplying variables, add the exponents if they're the same variable. So it looks like this. So again, 5 times 2 gave us that 10, and x to the third times x to the first give us x to the fourth. Now we're multiplying 5x to the third times 4y. And it's going to be the same procedure, except in this case we can't multiply x times y and combine those. So what we're going to do is we're just going to write them next to each other. So 5 times 4 will give us 20, and then x to the third times y will just be x to the third y. It'll look like this. This represents the fact that we tried to multiply together x to the third times y. We couldn't combine them in any way, but we could write them next to each other and say, well, they're being multiplied. So that is the correct and complete answer. We can take a look at another one, which is a double distributive property problem. For example, number 30, which is 6r minus 5, 6r plus 1. So in the previous question, you single distributed, but in this question, we're going to use the double distributive property. So as you can see, we did the double distribution here. We multiplied 6r times 6r, 6r times 1, etc. So I'll show you what the final product looks like. So this should be very familiar to you by now. Double distributive property gives us 4 different products. Now we have to combine like terms, which looks like this. So that should be your final product, your final answer. Let's take a look at one more. The final question that I'd like to look at is number 32. It's an example of expansion. Expansion is something that we talked about in class. We're taking 3x plus 5y and squaring it, which means we're taking 3x plus 5y and multiplying it by itself. So let's clear out some of this stuff that's here. Alright, nice and clear. Number 32, as I said, was 3x plus 5y squared, so here's what it looks like. Alright, so you can see we took the polynomial that was being squared, and we wrote it twice. Remember that this process is called expansion. We are expanding this squared binomial into 2 different binomials. Now we have to multiply using that double distributive property that I showed you before. So these products should look like this. 3 times 3 gives us 9. X times x gave us x squared. I have 3x times 5y, that gives us 15xy. Remember, we're multiplying the coefficients and also appending the variables onto the end if they're not the same. 15xy comes from 5y times 3x, and then 5y times 5y gave us 25y squared. My last step is to combine like terms, and it looks like 9x squared can't be combined with this term because it's only one x and one y. 25y squared can't be combined with this term either, but these 2 terms, the 15xy's, are in fact like terms, so we can combine these ones together. So we're going to identify that they are like terms by underlining them. And then our last step should be to write out the simplified version of this polynomial in standard form. So as you can see, we got 9x squared plus 30xy plus 25y squared. We've combined these 2 like terms. That should be our final answer. Now, I've only reviewed a few of the possible answers from that work, but I told you at the beginning of the video that I would show you all of the answers. So here they are. You can see all of the answers from question number 1 until question number 34. And you can actually see them 4 times. How about that? So if you need to check it over, pause the video and look at the answers that I've given you. Otherwise, good luck studying.